This is engineering statics problem from the study guide for test 1. And the question reads, determine the tension in cables AB and AC required to hold the 200 Newton cylinder weight in equilibrium. So important to note that this system is in equilibrium. Also, our 200 Newton weight has already been figured into a force, so we don't have to worry about that. If they just gave us mass, we'd have to multiply by gravity, but we're good there. So we can just go ahead and start solving this. First step needs to be to draw your free body diagram, which is going to look something like this. We have a tension over here of AC. We have a 200 Newton weight headed straight down, and then over here we have a tension of a B. Now for me, I like to go ahead and draw this out in a step 2 in forces. So for the TAB force, we have really forces in 2 directions because we have an angle. So we've got a force in the Y direction and a force in the X direction. Same thing for on the right hand side, it's at an angle, so we've got a force in the Y direction, force in the X direction, and then our last force is just headed straight down, only one force there of 200 newtons. To figure out these forces, we need to look at this 30-degree angle here. So our tension in AC for the Y direction is going to be the cosine of 30 degrees. And that's because this Y side is closest to our given angle. The tension in AC in the X direction is going to be the sine of 30 degrees. So that'll be really easy to figure out. For the left-hand side, we're going to use this 3, 4, 5 triangle that they've given us. So the tension of AB in the X direction is going to be TAB of 3/5. And up here, we're going to have TAB of 4/5. So I just got this from the Y side over hypotenuse side and the X side over hypotenuse side. So again, super easy. Now that we've kind of figured that out, don't think we're going to make any mistakes. We can go ahead and write out this equilibrium problem. So in the X direction, we are going to have TAB, tension in AB, which was 3/5 equals TAC sine of 30. So that's just saying here, pulling in this direction, we have a tension of TAB 3/5. Pulling in this direction, we have a tension of TAC sine of 30, and they're going to equal each other because we're in equilibrium. So we can simplify this and say TAB equals 5/3 TAC sine of 30, which is 1/2. And we can combine that and say TAB is 5/6 TAC. And that is a great relationship for us to look at later on. Now we'll look in the Y direction, add everything up there. Again, all our Y's have to cancel each other out and equal 0 or equal each other. So we are going to end up with TAC, and we have the cosine of 30 plus TAB 4/5 from our triangle, and that is going to equal 200 newtons. So now we can simplify. Cosine of 30, square root of 3/2, plus our TAB, and we have this relationship here. So TAB is 5/6 TAC. So we can combine some things here. We can cancel this 5 out, so that's going to give us TAC of 4, 6. Okay, we've got 2 TACs, so we can put them together. And we will find a common denominator for this. So we are going to say TAC plus 4 can go all over 6. And then I'm just going to use my calculator to come up with TAC. And that is going to equal 130,489 newtons. And TAB equals 5/6 of 130.489 newtons. Plug that in, and TAB equals 108,741 newtons. So those are our 2 answers. We've got our TAC, our tension in our AC cable, and our tension in our AB cable. And that's it for this problem.